Okay, it's working. So, hi everybody. I'm Gabriel. I'll be your host on this track, and I'll also be your host on the microservices panel. So, I guess you all had the fabulous conference so far, and it gives me great pleasure to introduce the next speaker, James Thomas. He's technology advocate for IBM on the Emerging Technologies Division, and he came from UK all the way for us. So let's give him a warm welcome and wish him luck.
Do I need to wear a mic, or can everyone hear me? Everyone hear me at the back? Okay, there it goes. So hello everybody, my name's James Thomas, and I'm a developer advocate working for... Oh, you do? Can I... Is there a headset? Alright, let's try this. So hello everybody, my name's James Thomas, I'm a developer advocate working for IBM in our cloud division. I'm here today to talk to you about building cloud-native applications and look at what they are, and how we can use the open source technology to do this. I'm going to attempt to do some live coding later on in the second half of this talk, looking at how to use this technology called Cloud Foundry to push traditional creative applications in the cloud, and then a little bit of some of the things we can do. But first I want to step back and think about what are cloud-native applications, right? Maybe you've heard the term in the media. What are the characteristics? And more importantly, why do you want to build them, right? If you're a company and as a developer, why is it important to you to build, I think, this new class of application? Because a lot of people think, and I did when I started working in the cloud, that I could, the cloud was just a bigger computer in someone else's data center, and I could take any application I built and throw it up into this virtualized infrastructure, and I would get all of the benefits of running on the cloud that companies like Netflix and Etsy talk about. And what I soon discovered was, my assumption was incorrect, it was wrong, I can't get all the benefits that a company like Netflix has of running on public cloud. We spent close to a decade thinking about the architecture of their applications to take advantage of the characteristics of the platform. And we actually need to, I think, fundamentally re-architect how we build applications to take advantage of these characteristics of the platform. But what I now think is that the ability of all companies to build what I call cloud-native applications can be crucial for all companies' success going forward. There's this amazing statistic, since the year 2000, 52% of companies in the Fortune 500 index have simply disappeared, they've gone almost overnight. These are companies that have gone bankrupt, have been acquired, have simply ceased to exist. And these are all major brands that you all recognise that have been around for 50, 60, 70 years that have almost disappeared overnight. It's companies like Kodak, Motorola, Blockbuster. So the question this leads to is, who's replacing them, right? Where's their business going? And I think in many cases, it's again, to companies that you would recognise on this slide. So Netflix, who started out with DVD rentals and moved into online streaming. We know what happened to Blockbuster. We've got Airbnb taking on the incumbent hotel industry, Uber with their taxis, Tesla with cars, Spotify and Dropbox. Now the average age of companies on this chart is just under 10 years old, but they have an average valuation of $27 billion. So what is it about these new companies that have come along so quickly? What has allowed them to be so successful so fast? And I think one of the things that they all do really, really well is their speed of innovation, the ability to have an idea, make a prototype, get in front of customers, get some feedback, and go through this iterative product development lifecycle. I think they are much, much quicker at doing this than a lot of traditional enterprises, which means they're much, much quicker at responding to changing customer demand, changing marketplaces. So what allows them to be faster than the competition from a technology aspect? What has changed that's allowed this? And I think, again, what a lot of those companies have done really, really well, the Airbnbs and Netflixes, is their adoption of cloud computing, right? This is what I think a cloud looks like. The ability to treat computing as a utility like electricity or gas, you can turn on or off on demand, you can provision in the cloud, which means, and the reason why I think this has allowed them to move so quickly is that rather than spending their time managing infrastructure and managing data centers, they can get their engineers to focus on building better products. And actually Netflix explicitly called this out in 2009. So in 2009, Netflix decided they're going to move all of their applications over to the public cloud and use Amazon. They wrote this great blog post detailing the reasons why they're making this change. And number 2, again, really spells it out. It says, letting Amazon focus on data center infrastructure allows our engineers to focus on building and improving our business. Now, as of this year, so 2016, they switched off the last bit of infrastructure. They haven't run any infrastructure anywhere around the world. And this has been one of the biggest and kind of most high-profile websites out there. So maybe now you're thinking, okay, right, I kind of understand, right? Come Monday morning, I'm going to go back into work and I'm going to get myself some cloud. I'm going to do this, say, well, I'll go to Amazon or Google and I'll provision myself some virtualized infrastructure and I'll throw my applications up there and I'll magically get all of the benefits that companies like Netflix and Amazon talk about without doing any changes to my application. Now, I know this is not a realistic scenario, right? You're not going to get all the benefits of running on public cloud without doing as Netflix cloud, thinking about the architecture of your applications to be able to kind of take advantage of the characteristics of the platform. You need to design your applications to run in the cloud. Because like I said, the cloud is not just a bigger server, it's someone else's data center. It used to be that when we had applications, we'd have something like this, or maybe we'd have 2 or 3, and we'd deploy our application onto it. We'd spend a lot of time kind of monitoring and optimizing and making sure it was happy all the time. And we wanted to scale, handle extra user load, right? We'd add more memory, more CPU, or more disk space, vertical scaling, right? Adding more kind of resources into a few constrained machines. But with the cloud, especially public cloud, the way that we scale is different. We don't necessarily add more resources to a few servers, right? We just add more servers. And now we scale horizontally by load balancing across all of those instances at the same time. So now we've gone from deploying our application to a couple of machines to potentially hundreds of thousands simultaneously. And also a big change about how we use and develop architectures in the cloud is the way that we treat the underlying infrastructure is different. And I think the best analogy for this comes from the people at CERN, people who built the Large Hadron Collider. When they were thinking about their journey to public cloud, they did this great slide that says how they treat their servers in the cloud. They said, we used to treat our servers like pets. We had a few of them, they're all unique, we love them very much. We spent a lot of time, if we got sick, nursing them back to health. But now we treat our servers like cattle. They're all identical, we're not really interested in individual cows, we're interested in what we can kind of do with them. And if they get ill, we don't spend a lot of time making them better, we just kind of deploy the application somewhere else. So we'll just get another cow. And I think that's a great analogy for how we treat infrastructure in the cloud. So the cloud is not just a bigger server, it does require us to kind of fundamentally re-architect our applications to be able to scale horizontally across hundreds of machines simultaneously, and to be able to cope with infrastructure failures and application failures as a normal part of operation without any kind of visible downtime. And this is where the term kind of cloud native came from, the ability to design applications that are designed to take advantage of the characteristics of a kind of public cloud platform. Now there's a wonderful book called Migrating to Cloud Native Application Architectures. It's published by a guy called Matt Stein, who works at Pivotal. Pivotal spend a lot of time helping customers build these kind of cloud native applications. And yeah, I think it's free actually because it's sponsored by you. So you go and read it, and I encourage you all after the talk to go and have a click through it if you're interested in learning more. But in the book, Matt lists 5 characteristics which he says make up our kind of modern cloud native application architecture. The first of those is something called 12-factor apps. Have people heard of 12-factor apps here? Is it kind of familiar? Yeah. So 12-factor apps came from the people at Heroku. Heroku, I think, built one of the first kind of modern cloud platforms. It was the first kind of big platform as a service offering. And based on, again, their experience of helping their customers move to their public cloud platform and build applications to exploit it, they came up with this kind of guidelines with these factors to help you do that. It's things like your application should be a series of stateless processes, right? It should be using kind of session state, so if your process dies, the platform can restart it. You don't need to kind of worry about kind of getting all that session state back into memory. And also, if we're running as kind of stateless processes, scaling becomes really easy. You can scale horizontally by adding more processes and then use the platform to load balance. So I don't have to worry about kind of replicating session state. It also said that you shouldn't be kind of relying on the underlying infrastructure, right? So if you're logging, right, rather than logging to disk and having a file, if that machine goes away, you're going to lose all the logs. Log to an event stream and use a kind of log management system to kind of handle this on your behalf. And the other thing that if you kind of look at all those factors, it's all about having all your configuration and dependencies for your application as code, as part of your deployment package, which means that the platform can be responsible for kind of starting up new instances when we want to scale. Right? We don't want a scenario, we want to kind of enable elastic scaling where every time we need to handle more load, some guy called Dave from IT has to log in over SSH and copy some config files back. Right? We want the platform to be able to handle things like that automatically. And if you go to 12factor.net, they've written up a full guide about how they think you can kind of implement this for yourself. And I think 12-factor apps are really the first attempt to codify what is a kind of modern cloud computing architecture. So the next kind of topic Matt moves on to in the book is around how they kind of microservice-based applications with API-based collaboration. Now, you know, microservices as a kind of a term is incredibly popular. If you go to any conference and go to microservice talk, it's always really, really busy. But really what it is, it's kind of an architectural style that talks about decomposing your applications, your services, or application services into a set of independent services that can be kind of ran and scaled independently. And what some of the benefits of this can be in terms of development speed, right? You can have multiple teams working in parallel on different services, and provided they've got this kind of API contract to talk to each other, they can actually kind of work without necessarily breaking each other. I think another great benefit is that you can also kind of de-risk introducing things like new toolkits or new languages, because rather than having to refactor your whole project to use a new language, you can try it out in one of the different microservices. You can actually have different services written in the language that's most appropriate for them. And I think cloud computing really enabled this kind of microservices architectural style, because you're not constrained by having a few physical servers to talk to, right? You can easily host dozens of microservices in the cloud with virtualized infrastructure rather than trying to kind of manage them on one or two physical servers. The fourth thing Matt talks about in the book is this kind of a nebulous term, I think. It's called self-service agile infrastructure. But what that really means is if you want to kind of move fast and be pushing products to market really quickly, right, you need a development platform and a cloud platform that's going to kind of allow you to do this, right? Again, you don't want to have to raise a ticket with IT and wait 6 weeks for someone to provision as a new VM, right? We want developers to be able to push code into production, have a kind of cloud platform that supports us doing that ourselves. Now, the last thing, and I think a really important thing in the book that Matt talks about is building applications that are anti-fragile, building architectures that are anti-fragile. And this term actually came from a non-technical book by an author called Nicholas Taleb, who's written another famous book called Black Swans, who you might have heard of. And Nicholas's book is really about, Nassim's book, is really about how systems respond to stress. And so some systems are very brittle, right? They respond to stress very badly. You can think of a glass vase, right? If I push the glass vase off the table, it doesn't respond to the stress of hitting the floor, it shatters into 1,000 pieces. But you have some systems that respond kind of well to stress, that actually get stronger. So think about your immune system. As your immune system is put under stress, it actually can learn from kind of viruses and things like that and actually respond to be able to defend itself better next time. And traditionally, I think how Matt talks about how the way we've kind of done applications can seem very brittle, right? If you get too many kind of user requests and too much load, you normally exhaust your resources and the server falls over and you get downtime. With the cloud, we can enable things like kind of elastic scaling, elastic load balancing. So when we get additional load, the platform can automatically be able to handle this. So maybe you're thinking, wow, that sounds like an enormous amount of work, right? You told me that I have to, I was excited about kind of building these cloud-native apps, but I need to build my 12-factor apps, and I need to do things like everything's got microservices with APIs, and I need a self-service platform, and it's got to be an anti-fragile architecture, right? How am I going to find the time to do this? And I think if you were going to start from scratch, this would be a tremendous amount of work. But what I'm going to kind of try and show you today, and then the second half of this talk, is I think there's a shortcut. But rather you can do everything yourself, you can use, my Java has told me once a day. Let me go back. I think there's a shortcut. Rather than having to do everything yourself, you can use an open source project called Cloud Foundry to help you do this. It provides you that kind of scalable cloud platform that you can deploy across lots of different infrastructure types. You can deploy it to the cloud, you can go to a vendor and use their instance. And I think it provides you with all of the building blocks to get started building cloud-native applications. Cloud Foundry is a platform as a service offering, which means that all you as a developer have to kind of care about is your code and your data. Everything else is taken care of by the platform, provided you follow the kind of guidelines about building your applications. Everything from the kind of runtime down is a platform's concern. You can focus on kind of building your application. Now, some of you kind of be using Cloud Well. I think while I use Cloud Foundry over some of the other options from Azure, Cloud Platform, or AWS, I don't think there's a number of kind of reasons why Cloud Foundry is a really good choice for cloud native apps. The first is that it's open source, right? So it's developed in open, it's run in the open, it's not a private vendor solution. You can pull it down, you can run it yourself, or you can deploy it using OpenStack to lots of different existing infrastructure providers, or you can go to a vendor like IBM, I'm going to show you, or any others, and actually kind of just sign up an account and start to use it straight away. But you're not tied into a private set of vendor APIs. I can move my Cloud Foundry application to any instance without any changes. Cloud Foundry is an incredible ecosystem, so it has an open source foundation that kind of looks at and makes sure it's developed in a vendor-neutral way, just like with kind of Linux and sort of Apache. And it has some of the kind of biggest companies in the world that are kind of involved with it, so people obviously like SAP and IBM and Cisco and Ericsson, so it's got, I think, a tremendous opportunity to be incredibly successful. And it means that rather than having to run this software yourself, you can go to one of those vendors and deploy your application there, and you're not kind of worried about being tied into a kind of private solution. I think that Cloud Foundry is designed for cloud-native applications, so it's a very opinionated platform, right? It won't let you take any application and throw it there and expect it to work. It forces you into this mode of building 12-factor apps and kind of force you to do that, which means that you can get all the benefits of the platform doing everything for you. So, how do we start? Right? If I had a kind of more traditional free-to-web application, what would be the steps to get this running on a kind of instance of Cloud Foundry? I'm going to actually kind of do a live demo now. Hopefully the internet's working. I'll show you how to do this. Obviously, I need an application, so I'm going to be using this kind of open source demo app that creates called Blue Chatter, which is just a very, very simple kind of web-based three-tier application. And if you go to the bit link at the bottom, you can get access to the code on GitHub. And everything I'm showing today is kind of documented now, so you can kind of follow along at home and kind of replicate. Architecturally, it's very simple, right? I've got a kind of Node.js runtime, which is serving my front end and exposing my REST APIs. And I'm using kind of local and development load, and we're using Redis locally to be able to talk and use the kind of hooks up functionality of Redis, which is a kind of database service that kind of allow my clients to chat with each other. Now, obviously, the final thing that I need to be able to run this on Cloud Foundry is I need an instance of Cloud Foundry. And as I said, it's open source and you can run it yourself, you can manage it to deploy it to lots of public cloud providers. But I think often what's easiest to do is go and sign up an account for a Cloud Foundry provider. And in this instance, I'm using IBM's cloud called Bluemix, and we provide you a kind of Cloud Foundry as a service where you go and sign up an account and get going straight away. But what I'm showing you today is not how to use Bluemix, it's how to use Cloud Foundry with the open source provider. So everyone cross their fingers and let's try to do some kind of live code. So let me jump out and I'll swap my display so that you can see. Okay, that's better. Oh, pick up my lead down. So this is the Blue Chatter application, right? So this is the kind of GitHub URL for it, and you can go, you can kind of read through and everything. What I'm going to kind of show you is kind of all of that, so you can go to that video. Now I imagine I'm kind of in development mode, so I'm developing this application locally, and I'll just show you what it kind of looks like if I go and start using it again. Okay, looks like it's working. I've got Redis running in my kind of local environment, and I can come back to my application. What calls are 1660, so change. Type on hand is a bit difficult. You know, I can say hello. You know, and anyone can kind of log in here. So this is like this kind of wonderful Cloud Foundry application. We want to move this from running in my kind of local development machine. I want to run it on Cloud Foundry, kind of look at some of the things that we can do. Well, obviously, as I said, you need an account with a Cloud Foundry provider, and I've kind of signed up my account with IBM Bluemix, which allows us to kind of log in while I look at doing that. And obviously you can then go and say, okay, create me a Cloud Foundry application and kind of run that. But this is about starting from scratch, right? Starting with kind of a blank runtime. Because what we have is we have a local application where we want to kind of run it. So what would we do? What are the steps to get that up and working? Well, the first thing you need to do, right, I need some way to talk to my instance of the cloud, right? I need some way to be able to push my code from the local development environment running on the instance of Cloud Foundry. And so to do that, if I go to the Cloud Foundry docs, I'm going to getting started. We're going to have this little command line utility called CF. And CF is, I've got installed on my machine, allows you to push your code into the cloud and then kind of manage it and scale it. And this will, you authenticate the client with the remote Cloud Foundry instance, and then you can talk to it really, really easily. So again, if you go to the docs, it'll show you how to install that. It's available for all platforms. But if I go into my console and kill my app, type CF, right? I've got the command line utility installed, and these are all the kind of things I can do when I'm going to push my applications to the cloud. And I can say things like, show me what applications I've got running using CF apps. And you can see I've already got lots of demos I've already been kind of working on in production. Right? So we've got some way to talk to my cloud. You can see that I've already authenticated, so I've typed my username and password, and that's my kind of endpoint at the bottom. So when you fly it, when I count the Cloud Foundry provider, they'll give you an endpoint, and this is what you authenticate the client with. So to move to another vendor or to another instance, I just have to update that API, and then I can push my application where I want. So I've got some way to, I've signed up an account with the Cloud Foundry provider, I'm running it, I've got some way to talk to it. Now I want to get my local code into the platform. There's only kind of one thing you need to do. Let's imagine that you follow the 12 pack approach about building your application. So you've got this kind of stateless process, and all your dependencies are included as a kind of management. How will I get my code into the platform? Well, you need some way to define what they call the kind of platform runtime, right? The platform's responsible for setting my application. How is it going to know what kind of, whether I need Node or Java, and what kind of application services I want to talk to? And we do that with something called a manifest. So I can open that up. So to say we kind of type this out from scratch and probably get it wrong and then be very confused, right? This is the kind of sample application manifest. I'll kind of run through the kind of very simple configuration that you need to get started. Obviously, I've kind of defined a name for my application, right? There's a blue chat app, that's what we're going to use to kind of identify and talk to it. You can set things like, when we're scaling, how much memory and CPU and kind of disk space you want each individual instance to have, and also, because we're going to be scaling horizontally, at least to begin with, how many instances we do need. We're going to start with one, and we'll look at scaling very easy after that. I've also said, obviously, how do I start my application, right? Because the platforms can be responsible to do this. I'm not going to be logging in over SSH and kind of managing that manually. So the next thing is, how do you configure your runtime environment? I've got a Node Jets application. I need Node.js installed. I need npm to install package repositories. I need the command to run npm install. Right? And the way Cloud Foundry does this is a really cool concept that I borrowed from Heroku, actually, called build packs. And build packs are essentially a series of shell scripts that you refer to that set up your entire environment. And the platform actually comes with build packs built in with pretty much all the major language and runtimes. So if I can go back to the Cloud Foundry docs. So out of the box, Cloud Foundry is this open source project. It comes with build packs to set up runtimes for Java, Ruby, Node.js, and Python, all the major languages and libraries and frameworks. And all you have to do to kind of instantiate that is refer in the manifest to the kind of Git URL for that build pack and at runtime, and the platform starts from the application, it'll run that build pack and get everything set up. You don't have to kind of manually configure that yourself. You can kind of configure it through config in the manifest. But I think the great thing about build packs is that you sort of the way you refer to them is just by a Git URL to kind of external kind of Git repository, which means that you can go and create your own build packs, and you can fork the ones that are open source and do that. Or I can go to GitHub already and see these are all the community build packs that people create. Right? So if I want to run Meteor or I want to run Clojure on the platform, I don't have to go and work out how to do that myself. I can just grab that URL, dump in the manifest, put some config in, and the platform will be able to start it up. So in my instance of my application, right, I've got Node.js apps. So all I want really is Node there, I need npm, and I need the platform to run npm install my package dependencies at runtime. And so I just refer to the Cloud Foundry build pack. The final thing is, how do you kind of talk to your application services, right? Because in development, we had a kind of Redis instance running locally that I was kind of talking to and managing. But one of the great things I think about Cloud Foundry is that the platform can provision your accounts in lots of different kind of application services, and it manages those credentials on your behalf. And then at runtime, it just binds into your apps that can read them and use them in the client library. So now if I need a kind of instance of Redis, I can manage this myself. I can use the platform to do that for. I can swap the credentials out really, really easily. So if I go back to kind of Bluemix, I can show you all of the different kind of systems and kind of application services that you can provision. Slow. Right, so these are all the different cloud-based services that you can bring. So rather than having to manage things like the database or caching system as kind of things that you take care of, we're going to use the cloud platform to do this. And if I go in and say, okay, I want Redis, so I want to provision a new account with Redis Cloud, and it will just give you that using a app runtime in an environment where it machines you. Your application just has to read that and use it, and now you don't have to worry about managing things like that. And you can go down and then choose the plan and kind of manage things like that. So I have already kind of provisioned an instance of Redis, and I've given it a name, Redis Chatter, and what we're going to do is just going to say, bind that to my application, and then I'll use that and not worry about kind of bringing it in production. So that is pretty much all you have to do. As long as you follow the 12-action approach, Cloud Foundry expects this kind of application, and we've defined our manifest. Now we can type this kind of icon magic command to get it into the system. Not oosh. Push. To see a push, I call this the magic command, because this is what's going to deploy your application, and we're going to, it normally takes sort of 30 to 60 seconds. We should have it running on the platform. We can look at things like elastic scaling and load balancing. So it's going to bundle up all your kind of local application code. It's going to take your manifest, and it's going to push this into Cloud Foundry. Cloud Foundry is then going to use that to start up instances of your application. You can see now it's binding, it's looking for that instance of Redis on the platform, it's binding those credentials, and they, as I said, they get passed to your application in an environment where all the cloud services. So all you have to do is read that, pass the data, and pull them out from the client library. And now it's going to, hopefully, it's going to substrate my kind of environment and get everything set up. I haven't had to log in and do any of this myself. I have to SSH in and kind of fiddle around and get things working. It's much easier. My developers can focus on building products, not on kind of managing infrastructure. So now we can see this is the kind of what's going on in the cloud platform in the background. It's using that build pack, it's now loaded in. It said, okay, it wants Node.js, I'm going to use version 12. I'm going to install npm, which is the way Node.js manages packages. And I have another file, package.json defined, which had all my dependencies. Now there's all my dependencies being loaded for my application. It kind of then bundles that up into kind of runtime binary that can move across any infrastructure in the background and spin up instances of my application. So hopefully in another 10 seconds or something, my application should be kind of running on our kind of public instance of Cloud Foundry, and anyone in the audience can kind of go to my URL and kind of start to play around with it. And again, I haven't had to do any manual configuration, right? I've just used the kind of Cloud Foundry platform. So it says that it's kind of all running, so you can see it has this URL. So I should be able to go and kind of copy it and say, James. See if I can go quicker than me. Right, and then say hello. Done, right? So there we go, right? It's running on an external URL, and anyone can go and kind of verify that. Now I managed to push it up to the Cloud Foundry cloud. Now what's the next thing that you probably want to do, right? You want to take advantage of that scalability that using that kind of brings. So traditionally scaling is going to be quite difficult, right? You have to find some more infrastructure and then worry about load balancing and failover and how you're going to replicate things like session state. With Cloud Foundry, it just becomes one command, right? We can use the CF command line again and just spin up more instances of my application on the command line and then kind of use the platform to do all the load balancing. I don't have to worry about someone else is in there as well. So if I say CF scale, and I can say my app's called Blue Chatter, say tech, right? What the platform's going to do now is going to take the thing I deployed, and it can just spin up those instances really quickly, and then the platform will handle all the load balancing and the routine. So because I've followed the 12-factor approach, the platform can do everything for me. So that seems like that was working. So I can say CF app, and check it's working. We can see hopefully 10 different instances have been kind of spun up. Right, so there we go. We've got 10 instances. If I go back to my application, hey George, if you notice at the bottom, this instance ID, right, so I refresh, what's actually happening, the platform is using a kind of round-robin approach to move your request between different instances. Because it's stateless, right, I don't need to bring out kind of replicating session states. I've been able to almost immediately scale up to kind of an extremely large number without worrying about it. When I don't need it anymore, all I have to do is use the commands to take them away, and then I don't need those instances. So you won't be charged for anything that you're kind of using. So you can scale elastically really, really easily, provided you follow that approach. Now, what kind of thing is you don't want to be sat in your bedroom at the weekend looking at how busy your application is and typing the command manually cscale every app, right? We want to add this kind of thing about anti-fragility into the platform and build this in. So you can actually use auto-scaling to handle this on your behalf. So if I go back to my application, compute. Again, everything in Power Foundry is kind of a service, right? So your database is a service, your caching system is a service, but also things like auto-scaling. So I can come into my app, and I can bind the auto-scaling service, and then I can define policies for scaling and scaling down based on things like memory usage and CPU. So I can say connections, there's my edits, connect to existing, and I've already provisioned an auto-scaling service, so I use it with some of my other apps. So I can find it down the bottom. Auto-scaling, connect. And now I can define a policy based on CPU or memory usage or some other custom metrics that will handle running that kind of CSCL automatically. So what this allows us to do is build that concept of anti-fragility into the platform, right? As my platform gets more user requests, auto-scaling will add more instances and then take them away when it doesn't need it. So my system's going to respond to kind of extra load by getting stronger and falling over and exhausting it. So there we go, right? So my app is running and it looks like it's got auto-scaling. So now, again, it's going to be able to handle doing that without me having to do anything. I can let the platform manage those kind of issues and not worry about it as a developer. So the final thing I kind of want to show you in the live demo is something that's called blue-green deploys or zero downtime deployments. Because one of the things, if you're using the cloud to move really, really quickly, to push new versions of your services out really, really fast, you don't want the users to have a server downtime every time, right? You know, if you have one physical server every time you push out an update, you have to take the application down, put the new code on, bring it back up, check everything's working. And that was a big problem, and if you're pushing updates multiple times a day, it isn't really going to work. But with Cloud Foundry, right, we can use the platform to load balance for a router to just automatically push a new instance of our version of the code against the platform at a different URL, and then use the load balancer to just move the traffic across really, really easily. So let's have a look now. So if I have all my apps running, now you can see that I already have, if I go back to my computer, I already have version 2 of Blue Chatter up and running, right? I pushed it this morning, it's called V2. And all I have to do is I just modify the manifest to use a different name. If I go to the application, you'll see that this is a huge improvement. So it's got blue background, it's called Blue Chatter. All right, and now I want to use the load balance on the router to move traffic across from my old version to the new version and not have to modify and handle that in my application. So I can use the command cfmap route. And what this does as well, and I can say Blue Chatter v2, my BlueMix. And give it a name. So now we're going to use the existing URL, the existing route, and Cloud Foundry will just load balance the traffic between these two instances. Now I can move some users over, check it's all working, and then decide whether I'm going to take the old application down. Just saying that it already exists. So if I go back to Chrome, I go back to my Blue Chatter somewhere. Now if I start to refresh, then you should see that some of the traffic goes to the new version, some goes to the old version. So I can use dynamically the kind of capabilities of the platform to handle this, right? I haven't had to do anything myself. And then when I've kind of verified everything's working, I can come back here and say unmap route from Blue Chatter app. So this works. So now I'm just going to take away the kind of the old route from the old application. And no traffic will go to that instance. You see, I haven't had to handle this amount, I haven't really had to do anything. I've been able to use the platform to do this automatically. So let me go and then click refresh, and hopefully no traffic should go to the kind of old instance. You can see that V2 is in production, and to the user there's been no visible downtime. The great thing is now I can leave my the V1 of the application running in the background with no route to it. If I get any problems later on, all I have to do is use the route to just push traffic back to it. So I can roll back really, really easy because I'm not constrained having one or two kind of physical machines. So that was, in the 15 minutes that I've been, having hopefully a relatively successful live demo, you can see that, provided that you follow the 12-factor app approach, Cloud Foundry makes it really, really easy to start building these cloud-native applications. So let me jump back to my slides. Let me my displays. So display area. Good. We'll just kind of wrap up what I've run through in kind of short amount of time. So I kind of start off by talking about what are cloud native apps and why are they important. And I think this has really come about from a pattern we've seen across all industries that there's incredible disruption, right? Over half the companies in the past 60 years in the Fortune 500 have simply disappeared. And you're seeing these new startups grow incredibly fast. But I think one of the things that's allowed them to do this is their adoption of cloud computing and building applications that are designed to run in the cloud, because it allows them to stop spending time managing infrastructure and spend their time building better products. And then we talked about what are the kind of characteristics, right? What are the 5 characteristics that a modern cloud-native application architecture should kind of be? And there's this great work that I do encourage you to kind of interested and find out more, go and kind of grab this for a while and have a little look. And Matt kind of codified, I think, things like microservices, anti-fragile architectures, and self-service agile platforms that allow you to build these new category of cloud-native apps. And then we looked at the kind of the how, right? And I think for a lot of people, the how can be Cloud Foundry because it allows you to jumpstart your development of building this cloud-native application. Provided this is an opinionated platform, so provided you have followed the guidelines in building 12-factor apps, you can actually get your applications running in Cloud Foundry and start to do things like elastic scaling, auto-scaling, zero downtime deploys with kind of minimal changes and minimal effort on the development part. So I'm going to kind of leave you with what I call this is called Cloud Foundry Haiku, and it was written or was tweeted by a developer who works on the platform. I think it really sums up what I think is great about Cloud Foundry cloud-native apps. And the haiku is, here is my source code, run it on the cloud for me, I do not care how. I think that sums up what I like about Cloud Foundry is that it allows you to stop managing infrastructure, managing deployments, and managing servers, and allows you to really focus on building better products. Thank you very much. I think we have 5 minutes for questions, or I'll be around if you want to grab again. So, thank you.
You showed the Redis and you said it gives you password username. It forced you to put the password username in your code. Do you have a solution for having it in configuration or something, injection?
Yeah, so I couldn't show you exactly how it works due to time, but what happens is there's an environment variable that gets instantiated by the platform when your environment, when your application runs. So there's it's called impact services, and all of your configuration is in there. So you don't have any username and password in the code itself. The code, your application just reads the environment variable runtime to pull out those credentials. So what that means is that, you're not storing any credentials in your code, you're using a platform to manage that. And there's a way in the platform you can just provide them yourself and say, here's my credentials for this service, even if you're the platform. If you don't want to use one of the Redis services that the platform knows how to talk to, you can just say, here's credentials for my service, and then bind that. And it means that you can do things like, I can swap between providers of a database, provide different Redis providers really easy. I just provision the new service, I bind again, and then to my application, it looks exactly the same. So it's a really great way to manage credentials in the system, and also means that it's much quicker. There's no coupling between your services and your application. It's just, here's the credentials, read that and use it. You don't know where it is, you don't have to manage it yourself.
Let's suppose that Blue Chatter V2 depend on depend on a database change. So in your scenario where you run side by side, the two versions of the apps, how do you handle this one where V2 would, let's say, have a different or a new database table?
That is obviously a more challenging thing to do. How do you run that production? I think it really depends on the application, the database, and I think there's ways to kind of manage that. But off the top of my head, I'm struggling to think about what you would do. I think it would really be very dependent on your application and your kind of data there and what things you can do. I mean, things that you can, kind of interesting things you can do, I'm thinking about this. So one of the great things instead is the way that your application reads credentials from database, it just reads from environment variables. So I can change those at runtime really easily. So when I push my application into testing, all that we normally do with Cloud Foundry is we bind test databases to it. So that's exactly the same. You can just bind, and then I can change the binding to use production in development. So often people have kind of test databases and different database provisions, and then without having to modify the application at all, we can just change the service binding at runtime, and then we'll pick up and work with that. So yeah, I think that challenge of zero down, what they call blue-green deploys, is something that lots of people kind of struggle with. It's probably a broader thing. I mean, people also do things like use feature flags, so they will push versions of their application which you can toggle off and on different features based on when the database update's been done. So they might push the code but not have the feature flag turned on, so the version 2 runs but they're not using that feature, and then when they do the database change, you can flip the flag and get it to run. So yeah, that's a challenge. That one the easy answer to that. I think they need to give you the line.
Can I configure my website to run with 2 versions in parallel? I mean, I want 5% of my users to see.
So at the moment, Cloud Foundry doesn't support being able to pass out 5% to this one, and they're working on those updates to the router. Because really, what you want to do is when I find the new version, the old version, I want to send just 5% and do all my testing and make sure my metrics or everything's still okay, and then slowly evolve things across. There is a kind of hacky solution at the moment. Is obviously you can modify the number of instances, right? So you can have 10 instances of your normal, and you can just push 1 instance of a new one, and then you'll only get 10%. Or if you've got 11 instances, then 9%. So that's how people kind of badly handle it at the moment. But they're working on updates to the router and open source project to allow that kind of stuff.
You mentioned blue-green deploys. I'm curious, I don't know what load balancer they use, but as far as my understanding goes, I'm guessing that they do sticky sessions, like something like they keep the old connections on the previous version, and
that's correct. Yeah, they have all the sticky session stuff, and there is also a way using the cookie. If your application needs, wants to have every client talk to the same instance when they come in, there's a way to manage that for your applications like so. Yeah, they use things like sticky sessions, so suddenly halfway through loading the web pages and flip over. Yeah.
Thank you.
All right, any more? Otherwise, it's lunchtime, right? So, one more last question, I think.
I saw you had some pre-configured services available services like Redis and some kind of database. Are they open source, and if you can give a short list of the most important provided services?
Yeah, so Cloud Foundry, the platform, actually comes with a dozen different big open source services built into it. Whoever runs it, you always get those out of the box, like MySQL, Redis, and MongoDB, and a couple of others. So every Cloud Foundry instance has those services available. What normally happens is all of the provider like IBM or HP or SAP runs Cloud Foundry. They add their own services in there to give you more choice. When I went to Bluemix, we've got like over 100 services, things like IBM Watson and all that kind of stuff. But they all have this core open source layer, and then most of the vendors will add some of their own services, the open source, and then third parties in there as well, so to make it really easy. So I couldn't list them all, there's way too many. But they call it, the key thing is the Cloud Foundry is the open source project. Comes with the core open source filters. They will always be there on what's any Cloud Foundry instance, and then the additional vendor ones on that kind of just for that. Alright, so thank you very much. I'll be around all day. I'll see the panel there if you want to chat or see some more live code, then come and chat to me. Otherwise, thank you very much and enjoy the